Hello and welcome to Yeyu Lab. Yes, we will continue to build our fascinating real-time chat application using Gemini 2.0 and its Multimodal Live API. This time, let's build a learning assistant with real-time voice and text interaction based on a shared drawing canvas. You might have seen the old video from OpenAI, which demonstrated how GPT 4.0 assists the students to learn math on the screen of Khan Academy by asking leading questions and providing hints to guide the student towards the correct answer. Let's have a quick look at it.
Hypotenuse is the longest side of a right triangle and is directly opposite the right angle. Can you find which one is the hypotenuse?
Oh, okay, I see. So, I think the hypotenuse is this really long side from A to B. Would that be correct?
Exactly. Well done. Now that you've identified the hypotenuse...
Actually, by using our previous screen sharing demo project, we can easily duplicate the same experience by sharing the screen of a learning website or document and operating some edit tools and let the Gemini 2.0 assist the user to learning the content. This is where the in-app document editor, specifically built around a canvas element, is necessary. By building our own interface for image uploading and editing, we gain more control and have higher scalability and flexibility for future features. So this is the new app for this video. Let's try it first. Upload one image. I will try an image from a math problem. Hey, can you help me resolve this geometry problem by finding the number of x?
Sure, I can help with that. Looking at the diagram, do you see any right triangles you can use?
This one?
Okay, that is the triangle on the left. Do you know the length of its two legs?
I know EC is 3, but I don't know FC.
Right, you know ESC is 3, and you are right, you don't know FC. However, you do know the length of FD, which is the sum of FC and CD. Can you use that information?
Yeah, but how I know the length of this one?
Right, you don't know the length of FC, but you do know the length of CD. Can you find it using the other triangle on the right?
This one, right?
Yes, you can use that triangle to find the length of CD. And since you know FD is 6, you can then find the length of FC. Do you remember the name of the theorem that relates the sides of right triangles?
Now let's see the design of our project. We will continue to use the same project structure as the previous screen sharing demo, but we will introduce some key changes in how the client interacts with the server and the Gemini Multimodal Live API. The significant shift there is that we replaced the screen sharing component with an interactive canvas element where the user can load images and make some basic edits using a drawing tool. The client also includes the audio capture, playback, text transcription, and the connection to the WebSocket for communication with the server. On the server side, the code remains the same as our last demo. That is, upon receiving a message, the server forwards both of the media components, image and audio data, to the Gemini 2.0 Multimodal Live API. And this image is captured from the canvas element. It's also responsible for receiving the stream response from the Gemini 2.0 and forward it back to the client to play. The voice streaming will also be fed to Gemini 1.5/8b model for transcript generation. and send back the text transcript to the client. Now we are going to walk through the code. Since the number of lines is a little bit big, I will only explain the most important parts of the code. If you want to see the full code, you can find and download it in my GitHub repository, which contains not only the project in this video, but also the previous ones in the Gemini 2.0 series, including screen sharing, transcription output, and camera interactions. Now let's start with the server side of the code. Install the dependencies, including both the two Gemini API. One is the experimental Multimodal Live API for Gemini 2.0 real-time audio and image interaction, which is the Google Gen AI with the version 0.3.0. This is a experimental library, so you must make sure the version is aligned because it will be changed very frequently. And also the production Gemini generative AI package for speech to text generation for the transcription by Gemini 1.5 Flash model, and the WebSockets and a PyDub, which is for audio processing. Together with a PyDub, you should make sure that the FFmpeg software is installed on your server. For Ubuntu system, you can use the apt-get install FFmpeg command to have it installed. The first section configs the key from the Google AI Studio access to the API through an environment variable and specifies the model that we'll be using in the project. Here we use the Gemini 2.0 Flash EXP for the real-time interaction and the Gemini 1.5 Flash 8B for speech-to-text generation because it's super fast and accurate enough for this easy task. The most important is it's very cheap. Then we create a multimodal client for the coming operations. The core of the server-side logic is the Gemini session handler function, which is called every time a new WebSocket connection from a client is established. It manages the connection with the Gemini's Live API and calls the send to Gemini and receive from Gemini functions as a background task, which are the main parts of the data processing logic. So in this function, first it receives the configuration data from the client, which includes the response modality to indicate the output should be audio format, and also the system instruction that guide the model to be a learning assistant, check the questions and answers from the students, ask leading questions, and provide hints to guide the students towards the right answer. So it will behave a very qualified math teacher. And then it established a connection with the Gemini Multimodal API and start a session with the model and config. The send to Gemini function manages the flow of messages from the client of the Gemini API. It takes the media chunks sent by the client and packages the audio and image data into the Gemini API message format and send it by the session send function. This is all done asynchronously, ensuring the streaming is seamless and the interruption tolerant. Then let's move to the receive from Gemini function, which is responsible for listening to the Gemini API's responses and forward the data to the client. We use a while loop that keeps running until the connection is terminated or an error is triggered. Once the model response is generated, we handled audio data, send it back to the client to play by using the client's WebSocket send function. Meanwhile, the audio data will be accumulated, and once the turn complete flag is set, the audio data will be sent to Gemini 1.5 Flash model for the transcription via the transcribe audio function. So there are two supporting functions needed. One is the convert PCM to MP3, which is used as its name suggests to convert the model response audio to MP3 because the Gemini 1.5 audio input does not support PCM format. Then this function called by transcribe audio function that will generate the transcript of the speech by talking to the legacy generate content method API by providing the prompt that tell the model to generate a transcript of the speech and do not include any other text in the response. If it cannot hear the speech, it can only say not recognizable. And that response test will be sent to the client WebSocket. Finally, the main function is very straightforward. It sets up the WebSocket server to listen on a specific port, let's say 9083. For each new connection, the Gemini session handler will be called to establish a session. Then, because the async IO feature is being awaited, the server remains running indefinitely. Now let's move to the client-side code, which is written in HTML and JavaScript. So moving over the HTML part and the CSS part, we have a simple layout with image upload, drawing controls and a canvas that shows the image, and also a transcript test area to display the transcription result. And in the JavaScript part, the render file on canvas function is responsible for loading the selected image onto the canvas. So here I only accept the image file, and you can also add more file type like PDF file to extend its usage. And it handles all the steps necessary to get it displayed correctly inside the canvas, dynamically update the canvas size so the image won't get screwed. We add the event listener here, which triggers the render file on canvas function to draw the loaded image onto the canvas. The capture image function is in charge of converting the content of the canvas into base 64, so it can be sent to the server along with the audio input in the period of 3 seconds for both image and audio. So you can find the first interval for capture image is set to 3 seconds, and another set interval for audio trunk is also set to 3 seconds. So you can adjust this number to make sure the balance between the real-time experience and the message integration. Finally, the start audio input function and the stop audio input function are responsible for managing the microphone access, working together with the talk button on the front end, and also capturing the audio and send it to the backend via WebSocket. We have already shown this in the previous video if you're interested to see the detail. As what we previously described, the receive message function manages all the incoming messages by displaying the text output for transcript and playing the audio output generated by the Gemini 2.0 model. I think those are the key parts of the code. Again, the full code is available in the repository linked in the description below for future exploration and experimentation by you. Now let's run the code. The procedure to bring up the web app is still the same. So first start the server by running the Python file. I need to point out that here I comment the system instruction to guide the model to be a learning assistant, since we already demonstrate the math problem resolving process. In the next round, I want the model to be more free to behave. So let's run it. So you see the WebSocket server is running on port 9083 as we expected. Let's take care of the front-end client. So here we have an index.html file together with a PCM processor JavaScript file to support the audio generation. Let's start the client by running the command under your project folder. Python command http server. Now your application running on port 8000 is available. That is our client server. Now we can access the local server on port 8000 and type the URL on the browse So let's try again for another demo to help me understand a table. Click the talk button. Hi, could you compare these two models?
Sure, I can help with that. The Llama 370B model has a slightly higher score in the MMLU Pro category, while the other model, the Llama 3.370B, has a slightly higher score in the MMLU Pro category. Both models have the same input and output pricing, and they have similar scores in the other benchmark categories. Is there anything else I can help you with?
So what is this benchmark and how the performance of each models are based on this benchmark?
Okay, let's analyze the IF eval benchmark. It appears that the instruction following IF eval benchmark measures how well a model follows instructions. In this case, the Llama 3.370B has a score of 92.1, while the Llama 3405B has a score of 88.6. This indicates that the Llama 3.370B model performs slightly better in this particular benchmark. Is there anything else you want to know?
That's it. Feel free to leave any questions or creative ideas you may have in the comments below. Thanks for watching, and we will explore more Gemini 2.0 multimodal techniques in future videos.